Thank you for coming to my session. My name is Timur Akhmadeev. I work for Python, and I'm from Moscow, Russia. This is my first time in Riga, and I'd like to thank the organizers for inviting me to this great conference. And thank you for coming to my session. So today I'm going to be speaking about the performance, of applications. About me, I'm a DBA now, and I've been a developer a long time ago. So I know how to read some Java, and I wrote some Java that I'm not proud of a little bit. But now I'm mostly doing some operational work. In between of being developer and DBA, I've spent quite some time doing some performance optimization work in software development company, and I know how to optimize code. So yeah, I have more than 13 years experience with database in Java. I'm interested in systems performance and architecture. I'm an Octable member, and I write some things here and there. So, and at the moment, I'm actually switching my job title to be Oracle Applications DBA as well. So, about the company that I work for, Python is a Canadian company which has headquarters in Ottawa and have many people around the globe supporting different clients. And we're helping companies adopt and manage disruptive technologies to better compete. Okay. So the agenda of today's talk is I'm going to be speaking about the architecture a little bit. I'm going to be speaking about what people do when they hear something about a performance issue happening in production environment. And I'm going to be speaking in how the numbers, how the numbers are misinterpreted. Okay, and I hope to finish earlier than expected. So we have 45 minutes and 5 minutes of questions, and I hope to finish in about 35 to 40 minutes. But let's see. It's the first time I'm giving these slides, so I'm not sure how much time it does take. So I'm usually working with the systems which are deployed in 3 tiers architecture, some enterprise systems. They usually have some load balancer, hardware or software, whatever. They have some cluster of application nodes, like 2, 3, 4, 10. And they usually have a database and some external systems as well. And the users are usually coming via HTTPS to the load balancer. They usually go to some application node, then some code runs. It goes to the database back and forth, gets some data, gets some reply to the user, gets the reply back to the load balancer, and gets the results back to the end user, right? And I don't have the specifics about the application here, and in general, it could be anything. It could be Java, it could be Python, it could be something else. It doesn't matter. So my talk is pretty much generic, as well as the database, although I'm gonna be speaking about some Oracle specifics, but that's gonna be just 2 slides or something like it. In general, my talk is vendor independent and could be applied to any system, any environment. So since those systems are pretty complicated, they have a load balancer, they have some applications and the database. Different people support the different parts of the application, like network people, like DBAs, storage admins, and network operations center, which is just people who are on call and just know some numbers to call and get the right people to fix some issue. And when a performance issue in such environment happens and some user reports that something runs slower than it was yesterday or a week ago or a month ago, usually some of those people, DBAs or developers or whoever supports the environment are checking different kinds of metrics and numbers. And the most common thing that they look at is the thing called the load. And the most common reply I hear when something happens in the environment is, I've checked the application, I've checked the database, the load is really low, under 5-7%, so we should be good. It should not be the database, or it should not be the application, or whatever. Another common reply is that we have a good I/O per second, whatever that means. And another reply is from network engineers is like, I see no issues in the network. It's whenever I ask a network engineer to have some reply about how the network performs, the reply I usually get is, there is no issues. Yeah, even if there are, okay. And when the numbers don't show anything, and people don't know what to do, they usually restart the application. How many of you do that? Okay. Yeah. Yeah. Unfortunately, the restart helps. That's the worst thing about the restarts, I guess, because when something helps, it gets to be like a common tradition. Like, if something doesn't work, we restart it, and we are up again. Okay, and it goes on and on and on, and the restarts happen like every week or even every day. Okay, and the management unfortunately thinks that it is acceptable, right? Which is not good. And the another common reply I hear is that when something is bad, we need to increase the number of nodes of anything. We need to have basically more hardware. We need to basically have more application nodes. We need to have more database nodes, and it should go away, right? So, but let's talk about the thing that I mentioned first about the CPU usage and how the numbers that are being interpreted are being analyzed are usually misinterpreted. So people are looking usually at the graphs like this, and this is 7 days, I guess, graph of the CPU usage of one of the application nodes, and it's taken from star output. And if you look at it, it follows the pattern of everyday activities, right? And during the day, the application is doing something, and the server is using some CPU, right? And if we look at how much CPU we use, it's not a lot actually. It's like under 30%, right? With a small spike here, which is like, I don't know what happened. But what's the problem with this graph? The biggest problem, there are many problems actually, and one of them is that the data that was used to graph this data is averaged at 10 minutes intervals, right? So if you have CPU usage averaged at 10 minutes intervals, anything can happen at 30 seconds interval. You can have a big spike and then do nothing, right? So this is hidden, of course. But apart from that, the thing which is hidden and usually is forgotten is that most systems now have many CPUs, and this system had 8 CPUs, so 8 cores. And if you look at individual CPUs utilization, you get to know immediately that the CPU number one, well, the title is not there, is getting used to up to something like 50%, not 25, not 30, but 50. So it's much higher. And if you think about it, it means that something goes pretty much not okay on the CPU, and you do some more work on one core for some reason. And in this case, it's like might not give any issue, but I've seen systems running one core to 100% usage, right? and doing that indefinitely, right? So the worst case scenario I've seen was a cluster of something like 20 nodes, where each node was using one core, exactly one core, for 2 years, and nobody was looking at it. But there was definitely an issue because there was an application bug and there was an infinite loop, and they were just doing nothing on single core, right? So this balance in the CPU usage is one of the things which is often forgotten. What else? Oh yeah. So 5% CPU on a 20-core system could be one core used at 100%. Yeah, that's what I told. So apart from that, when people are looking at the CPU usage and they see the number like 60%, the way they interpret the number 60 is that we have 40% spare capacity. And that's because the graph shows you, right? So you have 40% left, and people think, well, we have 40% spare capacity, right? Well, that's not true, because CPU usage is calculated as averages, right? And the CPU actually can be in two states. It can do something or it can do nothing. And the number of times it does something related to the number of times it didn't do anything at some averages gives you CPU utilization. So the graph is actually not like that. It's actually you have cores used up to 100% at some times, and you have some times where you can do something, right? So the 60% utilization means that you have 40% chance to do something on the CPU, and that's not the capacity, right? So you have the chance to do something. And queuing is inevitable because if you have some chance to run, you may either run or not run, and it depends on how scheduler schedules your work on the CPU. And funny thing is that the scheduling is not easy. And actually, Linux scheduler has well, I don't know if it still has a bug, but it had a bug, a really interesting bug, where a few guys realized that scheduler can lead to a situation where you have threads waiting to get on the CPU and scheduler not scheduling on the spare CPUs because algorithm that has been used for the scheduler is not ideal. It has bugs, and it's really hard to understand why you have like capacity on the CPU, but at the same time you have runnable processes which are not running, right? And this is quite nasty, I think. Okay, moving next is another number which is commonly used when the performance issue is reported is the load. Okay, sorry. There is another slide which is about hyperthreading that I forgot to mention. So hyperthreading, most cores now are hyperthreaded, and due to that thing that you actually have your physical core is only one, but you have multiple logical cores. This situation misleads the utilization, right? And it's not easy to tell you when the physical core is actually saturated. And it happens earlier than you actually hit 100% utilized, right? So getting to the load. The load is a number which is calculated by the operating system, and the Linux kernel says that it's a silly number, but people think it's important. I guess it says a lot about this number, right? So this number represents the number of runnable processes or the number of processes in uninterruptible state, whatever that means. And due to different issues with getting this number as up to date as possible, the calculated load is not precisely representing this, right? And it has some exponential backoff or whatever. So when you have the spikes in load, it's not necessarily gonna be represented as a change in the load, right? That's the first thing. And the second thing is that if you have changes in this number, it is not relevant and it's not directly related to the application performance, because you can actually do more stuff at the same time, and thus the load is increasing, right? It's not necessarily telling you that the performance of the application has become worse, right? Okay. So the next thing that I wanted to talk about is the I/O and how the numbers related to the I/O usually misinterpreted. So the first thing is that when people are talking about the I/O per second, they usually forget to tell you what was the size of the I/O and what was the service time distribution. Without those two things, the number of I/O that you do per second is pretty much irrelevant. Because if you are doing some big full table scans with a really large I/O, right? Your I/O per second might be low, but you're actually doing a lot of reads, right? And you need to do a lot of work. While if you're doing small reads, single block I/O, the number of I/O per second could be really high, and but actually you're not doing too much work compared to the full table scan, right? So it's really important to think about the I/O with the how big the I/O is, how and how much time does it take for the I/O? Like, what is the distribution of times, right? And the distribution of times is still not enough. And even if you have like a nice histogram of the I/O showing you that, I don't know, 95% of the I/O takes less than 100 milliseconds, right? Those kind of information can hide some issues that you have with I/O. Things like recurring issues. For example, if you have a stuck in I/O and your storage stops responding into I/O like every 5 minutes, for example, right? You might have a really small number of really long I/O compared to the total number of the input-output operations that you had. But the histogram is not going to show you that, right? And it's not really easy to find out that you have issues with the I/O with only the distribution as of time, right? You need to somehow uh, track the outliers, which are for some people a thing to forget. I don't know why, but some people like to just avoid looking at the outliers and saying, okay, we have just only 3, 4, 5, 10, 100 of outliers in an hour, and they don't look at it. I think that the outliers actually show you a lot, and they can show you that your system sometimes is really stopping and doing nothing, right? Another thing which is quite common to hear when people are talking about the I/O is CPU wait for I/O. I don't know where it comes from, but I have a suspicion that there is an I/O wait percentage which is showing somewhere in top or some other place. And the thing about this is that, oops, what happened? Sorry, I don't know what happened. So the CPU doesn't wait for I/O, right? Your code waits for I/O. The CPU can do something and then be idle, but it doesn't wait for I/O. Your code waits, right? So I think those words like CPU waiting for I/O are not entirely correct, and just avoid them, please. So what else? Percent utilization. If you look at the I/O stat, for example, and you see the number of which is showing you the utilization of some device in Linux, then just um, don't pay attention to it, because the number which is reported has nothing to do with how busy the device is, right? Because for the kernel, it is impossible to understand the limits of the device. And the only possible measure of how busy the device is how fast it responds to you. And the measurement of the utilization is not the percent utilization, which is often reported at 100%, but the how fast your disk respond back and how good your service time is, right? And percent utilization in most IO intensive applications is gonna be close to 100%. But that doesn't mean that your IO is saturated, right? Your device can do more, actually. And you just need to compare the service time of those disks and see if it's reasonable or not. And if it's not, then most likely you have something in your storage, but not necessarily, because you may also have issues on the path to the storage, right? So, thinking how bad your IO is actually not easy, I would say, right? So you need to be careful. Well, what else? I wanted to talk about the network, and as I previously said, network people tend to tell you that there is no issues in the network. That's because they are looking at the things like utilization graphs, like how much network throughput we are using at the moment, and they just compare it to some limits. And if it's below the limit, they think, okay, there is no issues, right? But it's not true. And networks are really, really complicated and hard. And the worst thing that can happen is that they fail at unusual times. And the application, many applications don't expect that. They are written under impression that the networks are reliable, they don't fail, and they are always gonna be working fine, right? But if you have some code which is doing some work under some synchronization block, for example, right? And doing some network calls, and those calls have no timeouts, they can hang, then a single packet drop can actually lead you to your application hang. And that's not something that is theoretical. I've seen that with applications that do not expect networks to fail at some point, and those that don't have timeouts on the network calls. Okay, so interpreting how your network is working is also not easy, and it's not enough to look at just how much throughput are you using at the server, right? It is more about the different stuff. So the what can I what is common with those metrics? And the common thing is the graphs, and there are usually some graph which represents time on the x and some metric on the y-axis, and the metric could be like CPU or the number of I/O, or it could be the or it could be something. But and people are looking at those numbers, right? And they are comparing to some limits that they think they hit, and the application would respond slower because they hit those limits, right? But um, what is missing on those graphs? The things that are missing on those graphs is that the application performance can be defined differently for different types of requests. You may have some functionality that can be run in like under 5 seconds, or in like 5 seconds, and that would not be good, right? But at the same time, you can have a functionality which runs 45 seconds and be okay. right? So those graphs, they kind of miss that because the application performance is in a different dimension. It's about the time it takes to dispatch a page, to run a report or something. And if your metric here it's not related to the time, it means you're not looking at the application performance, because the application performance it's about the time it take to dispatch a page, which in turn can be expressed in time it took to do a network calls, in time it took to do some work in the application, time it took to do some database work or whatever, right? But it's all about the time it takes to do the work. So keep that in mind, please. So whatever the um, database people are hearing the word time, they usually are going to the metric, which is called the DB time. And I have to say a few things about that. So the database time is usually represented as some percentage of the session time that was spent on different type of events, like doing some CPU work, doing some IO work, waiting on some events, and yeah, it's usually a big pile of time. And since I'm talking about performance, and I'm saying that the performance means time, I have to say that the database time is a good metric to look at the application performance on one hand, and on the another hand, it can be misleading, especially for the people who are looking at the database and those who don't look at the whole picture, those who don't look at the application as a whole. What do? They look at the database time. They look at how much percentages is spent in like CPU or IO, and they say, okay, we spent like I don't know 60% of the time here, so we need to optimize that, right? And that's the pretty common thing with database people. So that's kind of correct way to optimize the database time, which is perfect because if you optimize 60% of the database time, that means you're gonna reduce your database work by 60%, right? But what does it mean for the application? The application, or rather applications which are working with the database, they can do nested things, right? And some inefficient applications can use like 50% of the database time just to do some work. Okay. Um, Another application can use another 20% of the time, and the third application can use I don't know 10% of the time, leaving you to 20% of the database time left for other parts of the application. But the thing is that those three applications could be just not important, right? And the database people usually forget about that and they look at the database time without a context. And my opinion is when you look at the database time, you have to think about the context, and the context being module, session, action, and things like that, which can reduce the database time to a particular part of your system, right? And basically, the thing I keep saying is that 1% of your database time could be a performance issue within the application. And if you are considering that, if you're gonna keep in mind that, then you're gonna be okay in optimizing application performance issues, right? This is something that people tend to forget. Is like if we have 1% of the database time here, we probably don't need to optimize it. That's not true. You may have a functionality which is kind of important it runs 10 times a day and doesn't use a lot of the database time in terms of percentages, but still having performance issues, still having some slow SQL or too many SQL or whatever. And I guess that's it. I actually said everything that I wanted to say. So, as a summary, when you're looking at utilization metrics, you need to think, always keep in mind that the performance of the application may not be relevant to those metrics. And in my experience, 95% of the performance issues tend to be caused not by capacity issues, but they tend to be caused by the application and how the code is organized. Okay. The metrics which are commonly used to monitor the applications, they are misinterpreted in many ways, and I showed some of them. You have to keep in mind that the performance is about time it takes for your application to do some work. And when you look at the things like database time, you have to be careful and you need to keep in mind the context. So, as easy as that. Any questions?